Okay, today I want to talk about limiting reactants, and because I know students have been having a hard time with that, so I want to make sure that I go over a couple of things so that you can fully understand. Hold on a second, I've got to, okay, so limiting reactants, also known as LRs, okay? And first off, I want to give you a definition. A limiting reactant is the reactant that gets all used up, okay, in a reaction, okay? That gets all used in a reaction. That means that there's none left. And that's very important because in most reactions, you're dealing with one or more reactants, and oftentimes you have excess of one. And that excess is determined by how much of the other one you have. So it's very important in chemistry to understand the limiting reactant. Okay, so there's some steps that you need to follow to figure out the limiting reactant. And what I want to do is I want to go through those steps first, and in the next video presentation or the next lecture series that I'll do, I'll actually walk through a problem. So steps to follow, steps to determining, okay, to follow. First off, the number one thing to do is to balance the equation, okay? And let's even be more specific. We want to write and balance the equation, okay, which is the experimental equation. Number two, we want to calculate the ideal number of moles available. And I'm going to use a term here that I've been using in class, and that's ideally, okay? That doesn't mean that this is what you have to work with. This is saying that in the balanced equation, we have this number of moles plus this number of moles plus this number of moles of product and this number of moles of product. It's very important that you know what you're dealing with. Okay? Number three, identify the working amounts. For each reactant. And this is important because in most cases, this is the amount that's given in the problem. So you want to identify the working amounts for each of the reactants. 4, compare working amounts to the ideal amounts. Okay, and this will become very important when you later on, because you need to know, one, what the ideal mole ratios are, but you also have to know what you're working with so that you can make a comparison. Okay, and there's a couple of ways that you can do that. All right, and finally, the fifth thing is to determine excess. Oops. Oh, I have a hard time with that word. Determine the excess reactant. And that's important because then you know how much extra you're going to have in case you want to take the equation a little bit further. So in order to do this, what I'm going to do is I want to walk quickly through the steps, and I'm going to use a particular problem as an example. Okay, so my example, I have I'm going to have a reaction that uses zinc, elemental zinc, plus hydrochloric acid. Okay? And so what we can do is we know that zinc is a plus, hydrogen's a plus, chlorine's a minus, so we know that zinc is going to replace hydrogen in solution, and so we will end up with zinc chloride. Since zinc is a 2 plus, we drop a 2 there, and then we're also going to be left with diatomic hydrogen, or H2. And now what we do is we balance the equation, so we need a 2 here, and that balances. So let's go back up for a moment. Okay, so we balance the equation. We are now going to calculate the ideal moles. Okay, and the ideal moles are 1 to 2 to 1 to 1. Okay, that means for every 1 mole of zinc we use, we're going to need 2 moles of hydrochloric acid to react it all. So we're having a 1 to 2 to 1 to 1 ratio for this particular reaction. All right. Number 3, identify the working amounts. In this problem, we're told that we have 0.05 moles, 0.5 moles of zinc and 0.4 moles of HCl. And I'm going to erase this right here. Okay? So now the question is, which one is our limiting reactant and which one is our excess? So, knowing that we need 1 mole of zinc, in this case we are going to use 0.5 zinc, and we are going to need twice that amount of hydrochloric acid, which means that in an ideal situation, we need 1 mole of HCl. Okay? But the reality is, we only have 0.4 moles. Okay? We only have 0.4 moles. So instead of having 1 mole, we need to, because this is ideal, we actually have 0.4 moles HCl. Now the question you ask yourself, is that enough hydrochloric acid to replace all the zinc? And the answer to that is no. We need 1 mole, so that means 0.4 is 0.6 moles less than we need to react all of this zinc. So that indicates that HCl is our limiting reactant. Okay? HCl is our limiting reactant. Since we have 0.5 moles of zinc, we need twice that amount to react all the zinc, which means we need 1 mole, but we're only working with 0.4 based on what was given. So therefore, our limiting reactant in this equation is HCl. Okay? In the next lecture, I will actually talk about how to find excess and what to do with this information once you have it. All right, till later.